Today we're going to be reviewing for the Chapter 1 test that's coming up on Thursday. The first thing we'll do is write a few algebraic expressions for the verbal expressions. So we're going to write it using symbols and variables and operations instead of writing it out in words. So in words, the expression says the sum of 1/3 of a number and 27. So you want to dissect this sentence a little bit and think about what operations we're using. So we're using sum. We're using sum, and it says of, and then we have 1/3 of a number and 27 kind of grouped together. So you're going to write 1/3 of a number. The words a number always mean a variable. It could be any variable. So 1/3 of means multiply. So I'm going to write 1/3 n. And it says that we're going to add that to 27 because it says the sum. So our final answer would be 1/3 n plus 27. The next expression is the product of a number squared and 4. So the same idea as the last one. Here's an operation, and then you have a grouping, a number squared and 4. So we're going to write a number squared, meaning a variable squared. Product would be multiply. So since I usually write a multiplication problem where the number is in front of the variable with no symbol, I'm going to put the 4 in front of the n squared, and that would mean 4 times n squared, which is what it's asking for. Here we're going to do the opposite. We're going to write out in words or write a verbal expression for 5n cubed plus 9. So we write out the word 5, and 5n cubed means 5 times n cubed, so I need to write the the operation. So 5 times, we could write n as just n, or we could say 5 times a number, which represents the variable. And the number is the variable is being cubed, so I'm going to write cubed, or to the power of 3, either way. So 5 times a number cubed, and then it's addition, so I write plus, and I write out the number 9. Okay. Here we're asked to evaluate, so we're going to use order of operations, starting with the parentheses. Since there's 2 sets of parentheses, the second set is always brackets. So we start inside the brackets, inside the parentheses, which would be 12 minus 4. And that's going to give us 8. Then I continue to work within the brackets, or parentheses, and I have 8 divided by 2. And since the parentheses are directly next to the 3 squared, that means I'm going to be multiplying 3 squared by what's in the parentheses. So I'm multiplying 3 squared times 4. Then I do the exponents, though, after parentheses. So I have 9 times 4. So my final answer would be 36. Here we're going to also evaluate, but this time they give you an expression with variables. So you would need to plug in the variables first. W is 2, V is 8, and T is 4. So I look to see if I can do parentheses first, which I can. Here you either have a choice to use distributive property since you have a number outside parentheses, the 4 here, Or you could do what's inside the parentheses, since you can combine 8 minus 5. If you have a problem where you cannot combine what's in the parentheses, then you are forced to do distributive property, and that's the only method you have. But since we have numbers that can be combined inside the parentheses, you could either use distributive property by taking the 4 and multiplying it to the 8, and then taking the 4 and multiplying it to the 5 and subtracting that, or we can do 8 minus 5 first, and that would give us 3, and then multiply after. And since multiplication comes before addition, I'm going to multiply and multiply. So 4 times 2 is 8, 3 times 4 is 12, and then my final step would be to add. This is one we saw in class earlier today or yesterday during our Jeopardy review. It says name the property used in each equation, then find the value of n. Like I said, you might want to make flashcards of the property examples on the front and then the property that it is on the back to help you study. But here's one example where you have 11 times n equals 1. So you need to figure out what would you need to put in for n. Anything times its reciprocal is always equaling 1. And the property that says that is the multiplicative inverse property. And since it's using the multiplicative inverse property, that means the n would have to be the reciprocal of 11. So 11, if you think of 11 as a fraction, it's 11 over 1. So the reciprocal of that is 1 over 11, and that would be n. We're also going to name the property for the next two. If we look at 6 plus 0 equals n, we know anything plus 0 equals itself, so n would have to be 6. And the property that tells me that is going to be the additive identity. And then the next problem, also looking for a property, you can see that they've taken away the parentheses for the n, so meaning you need to do the parentheses to get the n. Since I'm doing something in the parentheses, and that's all I need to do to get the n value, that means I'm using the substitution property, because I'm substituting what 3 plus 2 is in for n. So substituting, or substitution property, and that would mean n has to be 5. This next example, you want to evaluate the expression, but also think of a property that you're using in each step. Whenever they ask you to do this, you always think about how you could solve this easily in your head, while also following order of operations. So we're going to start with the parentheses. We need to do multiplication before division. So we have 6 times 1, which is 6, and 6 divided by 36, which if you write that out, okay, what I first did, all I've done so far is substituted, so it's the substitution property. But then I need to look at what 6 divided by 36 can be written as, and you can write that as a fraction. So, and you simplify the fraction. So you have 6 over 36 and times that by 6, but you first need to simplify the fraction. So again, I did 6 divided by 36. All I did was change the form, so I actually didn't really use a property, but I'm going to simplify the fraction, which gives me 1/6, because I could divide both 6 and 36 by 6. So I'm left with 6 times 1/6. Now if I'm simplifying the fraction, I'm substituting it with the new fraction. So I have 6 times 1/6. Okay, so if I did that, I also am using the substitution property. But then my last step, I have 6, which it can be written as 6 over 1, times 1 over 6. And as we talked about with the last couple problems, there was one where you have reciprocals and you multiply. So when you multiply reciprocals, you always get 1. And if I did that, I'm using the multiplicative, running out of room here, inverse property. And that would be my last step. Here we're using the distributive property, which I talked a little bit about already, but whenever you have something directly outside parentheses and inside the parentheses you have an addition or subtraction problem, you're supposed to distribute what's outside the parentheses to every part inside the parentheses. And I usually show that by using arrows. And when I'm distributing, I'm multiplying. So I'm going to take 5 times 10, keep the same operation in the parentheses, which is plus, and then I'm going to do 5 times 3. So that would be rewriting this expression using the distributive property. Now I can simplify this more because I can multiply and then I can add. So I'm going to do 5 times 10 first and 5 times 3 first to follow order of operations. And I get 50 plus 15. So my final answer would be 65. Here we're going to simplify a few expressions. Here we're looking for like terms. Like terms have to have its same variable and same exponent. So if you look here, you have w squared. You also have w squared, but then you have z squared. So, since the w squareds have the same variable and same exponent, I can combine the numbers and add 4 plus 7. And then you bring the variable and the exponent along with that when you're adding or subtracting. So I'm going to have 11w squared. And then since I can't combine the z and the w, since they have different variables, this is as far as I can go. I'm also simplifying here. So you can see here that you can actually do distributive property first, which you should, if you ever see that you can. I have to use distributive property because I cannot combine like terms within the parentheses. So I have to distribute what's outside the parentheses to each part inside first. So I have 3x plus 4 times 5x. Use the same operation as inside the parentheses, so plus, and then 4 times 2, because I want to distribute to both 5x and the 2. So I keep going, and 4 times 5x, sorry, my computer is acting up, 4 times 5x is going to be 20x, and 4 times 2 is going to be 8. So then I look at all of my variables, and I have these as x and this as x, so I can combine those two. And again, just bring the variable along and add the two numbers. Since I can't combine a number without a variable with a number with a variable, this is my last final answer. These next problems, you're really just trying to do it in your head as quickly as you can. So to evaluate, you want to think of what can I do that are compatible numbers, and I'm going to do that first. So you may just want to go left to right here, or you could do 5 times 4 first, and then multiply that by 13. Now the times 1 is not really going to do anything to this problem, because anything times 1 is itself. So 5 times 4 gives us a nice easy number of 20, and then if I take 20 times 13, I'm going to get 260. And then 17 plus 6 plus 3 plus 14. If you think of compatible numbers here, 17 plus 3 gives you 20, and 6 plus 14 gives you 20. So if we do 17 plus 3 first, that actually means that it doesn't say to write the property here, but it actually means that I'm moving the numbers around, so I'm using the commutative property here to do 17 plus 3 first. and then I have 6 plus 14 second. If I did that next, I would get 20 plus 20, which is 40. The next one is where you're asked to find the solution, and they give you an equation, then they give you a replacement set of numbers. So here you're just supposed to replace the x with each set of numbers, or each number, and see whether one side equals the same number as the other side. So if I plug in 5, okay, I have 3 times 5, which is 15. 15 minus 8 is 7. So 7 does not equal 16. So that means 5 is out. Then I do the same thing with 6. 6 times 3 is 18. 18 minus 8 is 10. 10 does not equal 16. So 6 is out. Then you have 7. 7 times 3 is 21. 21 minus 8 is 3. 3 does not equal 16. I'm sorry, did I just say 21 minus 8 is 3? 21 minus 8 is 13. 13 does not equal 16, so 7 doesn't work. Then we have 8. 8 times 3 is 24. 24 minus 8. 24 minus 8 is going to give me 16. So 16 does equal 16 here. So that means 8 is my solution, and I don't need to go any further because I already found my solution. Here is more practice with solving using order of operations. When you have a fraction, you need to do the numerator and the denominator first before you divide at the end, since the fraction bar is the same thing as a dividing bar. So I'm going to choose, it doesn't matter numerator or denominator first, but I need to do both. So 6 plus 4 squared times 3. If I do the numerator first, I start with exponents. I get 6 plus 16 times 3. If I do order of operations here on the numerator, I'm going to get multiplication before addition. So 16 times 3 is 48. 48 plus 6 is 54. And then 10 minus 1 is going to give me 9. So then I finally divide at the end. So 54 divided by 9 gives me 6. Here you want to look at the graph. It's a graph of bowling scores. You can see that the y-axis is labeled with scores and the x-axis is labeled with the game number. So you're supposed to identify the independent and dependent variables. The shortcut here is that the dependent variable is always the y. So I can easily say that the scores are going to be dependent variables and the game numbers are going to be independent variables. But I can also ask myself, what depends on what? So does the score depend on the game, or does the game depend on the score? Think about, are the games going to continue no matter what your score is? Which they are. So the games are not affected by the score. The score, though, is affected by what game you're in, because it depends on how you're playing that game. So since the score is affected by the game, or it depends on the game, the score would also be the dependent variable. And then whatever is not the dependent variable is the independent variable, so it's the game numbers. This is the same graph, just a little bit more detailed. I have 4 ordered pairs here. We're supposed to describe what may have happened between the first and the fourth games. You can get a bit creative here, but you can see between the first and the fourth games there was a spike up and then a drop down. So think about what might have happened between the first and fourth games. I was thinking maybe it could be between the first and the third games he was becoming a little bit more comfortable with what he was playing and he had some experience, and then by the fourth game maybe he got tired or maybe he got distracted or something like that. So that's all you really would need to say. But as long as you're describing the pattern that's in the graph with the subject matter of the graph, then that should be an okay answer. Okay, we only have a few more problems here. We have a table, and they give you the weight of a certain object and then the rate that it costs to send that object somewhere. So this is asking us to write the data as a set of ordered pairs. I don't always want to assume that the left side is x and the right side is y. What I want to do is I need to find out which one depends on the other. So if I think about the weight of a package, the weight is going to depend on, the weight is not going to depend on the rate that it costs to ship. The rate that it costs to ship is going to depend on the weight of the package. So since the rate is dependent, we talked about how the dependent variable is always y, so the rate numbers are our y's. So if I were to make these into ordered pairs, I basically would just take the first number, comma, the second number, and put it in parentheses. And I'd continue to do that for each one. So the next one would be 3, 275. Then you have 4, 370. And you don't have to put the zeros, as you can see. And then 5, 465. So there would be your list of ordered pairs. They also call this a set of ordered pairs as a relation, just for future reference. Here we're asked to draw a graph that shows the relationship between the weight of a package or a letter sent by airmail and then the total cost. So if you think about it, we talked about how the weight and the cost, they depend on each other. So you have the cost is going to depend on the weight. Okay, so that would help us create our graph. And you have the weight as your x and your rate as your y. And you think about how the weight of the package, the more heavy it is, or the heavier it is, it's going to have a higher price to send. So you can kind of just do straight increasing line to show the relationship between the weight of the package and how much it costs to send. And that would be sufficient. Finally, we're going to interpret the end behavior of the last function. So if we look at the graph again, we have the weight is going up and the rate is going up. So you can assume that it will continue to climb. The higher the weight of the package, the higher the rate. So that would be how you would describe the end behavior. The higher the weight, the higher the rate. And that concludes the Chapter 1 test review. You will see examples of almost all of these types of problems on your test.